My name is Hamlet D'Arcy. I work at Canoe, and thank you for having me here. I'm going to talk about code generation on the JVM. I'm one of the project committers on the Groovy language, and this is an area that I really like to work on within Groovy. We've added, it's not just about Groovy, there's also some Java technologies involved, but this is an area that we saw some big improvements in Groovy 1.6, Groovy 1.7, and we're working on new generation for Groovy 1.8. I'll also be talking about some non-Groovy technologies.
May I ask you to speak up a bit, please?
This has nothing to do with it, I know. So my name's Hamlet D'Arcy. I work at Canoe, and they were nice enough to have me out here, and so was the group. I'm on vacation, so after this, I think it's a party. One bit of trivia, my Linux laptop decided to die this morning, and this is my wife's Macintosh, and so if you see me fumbling with the keyboards, I do know how to type, just not on this keyboard, so all the keyboard shortcuts are different now. But you know, it's fun. So code generation on the JVM. Has anybody worked with these wonderful technologies? It's amazing that I feel like it's amazing that I still am interested in code generation after living through a Corba stub generation, WSDL generation. These sort of technologies have really made some nice nightmares for me over the years. And they all share something in common. They usually involve a build step that ends up creating all of this machine source code, usually actual Java language source code in a lot of these. And they say, well, there's this great build step, and it makes everything invisible for you, and you don't have to worry about this generated code. But then you end up stepping through it in a debugger and trying to decipher what the heck is going on. So these are the code generation techniques that I'm really not interested in doing anymore, and they do have something in common. The ones that I'm a lot more excited about that I'm going to focus on, I'm not going to just tell horror stories. I'll tell some nice stories too. These are some of the code generation, I would say modern code generation libraries and frameworks. In the middle is Project Lombok. This is a code generation library for plain old Java. Has anybody used Lombok or seen it? All right. Yeah, that's good. Groovy, Spring Roo is down in the right-hand corner. I'm not going to talk much about that tonight. We will talk about Boo. Boo is a .NET language that has some very interesting code generation features. And then in the corner, Lisp. If you want to talk about code generation, this is one of Lisp's strong points. Maybe one of its weak points, depending on how much time you've spent debugging Lisp macros. But we might look at that at the end if there's time. So Project Lombok. Is Alt tab supposed to? There we go. So Project Lombok is a pure Java technology. This is a person, plain old person object. I have some imports in there, and that's just to make my life easier. But this is a plain old Java class. We can call Java C on it. Actually, just so it compiles, Java, compile it, person.java. It should compile. This, of course, creates a class file on disk. And has anyone used Java P? Java P is the bytecode. It's a bytecode analyzer, I guess. So if you use Java P and you point it at a class, a fully qualified class name, there is no package in this example. It's going to tell you what's actually in that class file. So JavaP reads the class file of person.class and tells you, can everybody see that? And tells you that it is a Java object, it extends object, it has a first name and last name field, and a public person method, right? And the Java boilerplate that everyone's familiar with is getters and setters, right? There's somewhere here, if I knew the shortcut, you would have to normally in plain old Java generate all of the getters and setters for this. And this type of boilerplate is what Project Lombok is trying to eliminate. I'm just going to, with Lombok, let's annotate these fields. The first name has a getter, and last name has a getter. Java C -cp. I'm just going to put Lombok on the class path. I'm not going to have to deploy it. I'm just compiling with it. If we compile person.java and look at the bytecode of person.java, 2 new methods showed up, getters. Project Lombok works with Java C, obviously. It works with Eclipse, the IDE. If you were to hit Control Space in Eclipse, up would come the auto-completion, and you would see get first name on your person objects. That does not work across all platforms. It's just on Java C and Eclipse. So if those are your Java technologies, this is something, if that's your standard tools, this is something you can use. Let's do, and obviously, shouldn't really be a surprise, but if you do @setter, your setters show up as well. Set first name. So the point of Lombok is to take all this boilerplate out of bean generation. And it's not putting anything into separate files. It really is just compiling down to the class file and then adding getters and setters for it. A couple of the other interesting annotations that ship with Lombok is @data. This is a shortcut to do pretty much all of the features that are available in this framework. So I compiled it with Lombok, and now you see you have getters and setters for all your fields, you have an equals, and you have a hash code. These are configurable annotations, so if you want to keep an ID field out of your equals because that's how your database works, or probably just make equals be the ID field, you can do that within Lombok. The point of this is to take all of that getter, setter, boilerplate out of the Java source file and just make it disappear, right? And this is the primary use of Lombok. There's also a couple others. There's a @synchronized annotation, and let's see if we can get this to work. No. Okay. So this is the before and after. With Lombok, you have the nice terse code. Without, you have something very, very long. It's not like this is code that's hard to write, but you have to look at it every time. @synchronized is the other example. What @synchronized does for you is instead of using a synchronized method, which is going to make your synchronization policy for concurrency and locking be part of your object's public interface. It will wrap it up it'll create a lock field for you and then do private synchronization. It's a 0-element array because then it's serializable. A new object isn't. They're considering a few others that there's a few other transformations as well that they're doing. As we'll see later, Lombok is sort of also feeding into the Groovy language. Some of these have been copied and put in the other languages, and vice versa. Some of the Groovy annotations and transformations that are in use are being put into Lombok. One of the cool part about Project Lombok is that if you decide you don't like it, there's a command you can run called dlombok, and it takes all of your annotations and removes them from your code and writes in the code, the source code that you would have written if you hadn't been using the library. So if you want to try Lombok on your project, you can use it. And when you decide you don't like it for whatever reason, there's an automated step to tear it out. And a word of warning, the documentation is good, but it has some small print at the bottom of pretty much every one of these features, and you kind of need to know how it works. For instance, just because you are given an equals and hash code method, you still need to know what is equality for the object, and you need to know how that equals works. And so sometimes it might be beneficial to actually have an equals method in source code that you're looking at rather than make it completely disappear. If equals method is important, then you should probably put it in your source code. But there's fine print to read with Lombok. Moving on to Groovy. There's a couple features in Groovy. Here is a terminal, if I could use the keyboard. There we go. Here's a terminal. So, event.groovy. This is just a plain old Groovy object. Is that big enough? Okay, so this is just a plain old Groovy object. There's no fields in it, but if you want to add one, it has a date time or something. So this is on disk. Let's see, ls event.groovy. Okay, so it's there. If I want to compile this with Groovy C, so the Groovy C is the Groovy compiler. If you're probably not invoking it specifically from the command line. You're probably using Grails or another framework that takes care of it. But Groovy C is the compiler for Groovy, and it does run for every single Groovy object before it's executed. That's not good. Cool. I've given this presentation before, and there is a class file there. It's not .class. Yes. Groovy C worked. Yeah, it's an amazing technology. It really is. You know what? And they say don't check class files into version control. And here's the perfect scenario where you want class files in version control. I'm glad it's not in my ignore list. So this is the Java C output. Ooh, that's really kind of bad, huh? This is the Java C output for a Groovy class, and you can see there's a whole bunch of stuff there. The source code was just a string field, right? And the actual bytecode that it produces has all of these get meta class and set meta class methods on it. Let's see, there's some interesting ones here. Like, well, it won't have the name, but get, well, this sucks. Get when and it does, and that's the point. It has the get when and the set when in there. And so if you wonder how does Groovy allow you to do property access? You know, new event dot when. Well, it just pipes it through to get when. And if you want to know why Groovy has great interoperability with Java, why you can use a Groovy bean in like the Spring framework and just sort of pass it in without Java knowing about Groovy and method dispatch, is because the actual class file has these get win and set win methods on it. And one of the so this is something that has existed in Groovy since day one, and then this is the type of thing that Lombok took and said, we want a similar code, generation step for Java, but we don't want to have to use Groovy for it. A more interesting one is is @delegate, and what this does is @delegate will make event have a date. I mean, it already has a date, but the public API of event will have all of the public API of that Java util date on it. So if you want to say new event dot before, before something else, before is a method on Java util date, after is also a method on it. The actual bytecode of event will have all of that same public API. So the point is that with a small change to the language, you can have it to be very easy to prefer composition over inheritance. So normally the easiest thing to do to make your event in Java look like a date is to extend the date class, which brings all sorts of side effects that you probably don't want. Equality being a difficult one to deal with. And so @delegate is a shortcut to try to make these better designed systems. Yeah.
So all annotation for Groovy, it's not for Java.
It is for Groovy right now. It's on the roadmap of Lombok. It's on their site as something that they want to add.
It's possible to write our annotation and extend to Lombok or
I don't think Lombok really has a plugin system. The point of my interest in Groovy is that back when Groovy first came out, when I had nothing to do with it, and I still have very little, adding a getter and setter to the event class was something that a Groovy core developer had to do. Somebody that writes the language had to write the code that generates getters and setters. @delegate is all capitals. @delegate is in Groovy a AST transformation. This is a feature of the Groovy language, and it is a part of the Groovy core language, but there's nothing about it that could not have been written by anybody that was a Groovy author. There's a feature that I'll talk about it more later, but the feature of the language allows you to do this code generation. And that's what I think is special, is that to do code generation and make these really nice class files, you don't need to muck around with the language anymore. You don't really need to be a language developer. You just have to know about one of the features and write a transformation. And we'll see. I have a couple examples. Let's see if I can get the slideshow. It hurts me to use the mouse. I'm really a keyboard guy, and so here's the before and after. This is on the left. This is what you would write in Groovy, and on the right is what you would write in Java, just with getters and setters. I showed you @delegate. This is the code that is produced if you were to actually write it out by hand. We need a bigger screen. @lazy. @lazy does lazy instantiation. So instead of hand coding all these null checks and saying, and doing some sort of double checked locking around synchronization, @lazy does that for you. And so it will lazy initialize a field. It will lazy initialize a field for you. This is Groovy 2, and Groovy 1.7 can be downloaded. And it handles volatile and initial values. So it's not that simple to write, I think. And @immutable is one that I've been using on a GWT project. That's big enough. So @immutable tries to make the class effectively immutable. And if you do something within the class like mutate values, it will not allow you to do that. So in this case, @immutable would not generate setters for you. It would generate a constructor for you. If it knows about the JDK types that can be effectively immutable, such as dates and color, if you'd make a defensive copy of dates as their input and a defensive copy as they're returned in the API, a date can be immutable. And so @immutable is another language feature that there's a whole bunch of rules around it of what makes an object effectively immutable. But for people that are interested in concurrent code, I think an @immutable annotation is a much better, a much easier way of creating immutable objects and still without a lot of boilerplate. And then there's a whole bunch of others. Groovy 1, so the current version is Groovy 1.7, and there's a few additional features in Groovy 1.8, and I do want to cover those because some of them are my nights and weekends, so it's hard not to be excited. @log is going to, this is working for everything except commons logging, but logback and log4j and SLF4j are all supported. But @log on a class is going to inject a logger into your class based on your class name. And if you do a log.debug statement, it's going to defensively wrap that statement in an is debug enabled statement. And so the parameters will not be evaluated if that type of log message is not enabled. So all of this boilerplate of just saying, is debug enabled true, then do my debug message would disappear. Yeah. And @synchronized was blatantly stolen from the Lombok project. So @synchronized is coming to Groovy. Inherits constructors would give you all of the constructors from your parent object. And all of these would be in the actual bytecode. So, when you look at it with Java P, which is basically the same API that other Java classes are using to access your class, you're going to see those methods. So I'm a fan of a few things, Spring and dependency injection being one of them, and I think having some objects be Groovy objects and giving them out to be used by Java objects is very helpful. So in the actual tooling across all of the platforms, you're going to see this. So yeah. Well, yeah. So I think it's a debatable point. I believe that your synchronization policy should be private to your class. And if you use a synchronized method, that implicitly synchronizes on the this block. And so anybody that has an instance of your object can say synchronize on that object and effectively create their own deadlock or create their own deadlock. Is that going to happen frequently? No. But at the same time, having but it avoids the issue. I think the reason it's not more common is because synchronizing on the method is really easy. Just write synchronized at your method and it's done. And it's the same with inheritance. It's really easy to inherit from a class. It's hard to make an actual delegate. You have these classes with one field called proxy or delegate, and then a whole bunch of methods that just say this, delegate.x, delegate.y. And I think making it, I do use @synchronized. I think making it easier to sort of do the right thing is what that's about. The problem with that is that in your Java doc, you don't actually see that a method is synchronized anymore. So the visibility does suffer a little bit, and that's a good criticism of why to make it public, is that the other tooling picks up that and uses it. So does anybody know what this is? He does know. Yeah, it's the, there was nobody on board, so this is not in poor taste. This is the Ariane 5 rocket that blew up. This was an integer overflow error, right? They were, yeah. $370 million in damages for an integer overflow. And that sounds really high, but you know, the Greece bailout was 145 billion. So we're not bankers. That's the good news. We're so much better than central bankers right now. We should be proud of our profession for that. This is our biggest disaster. Enough politics. So the reaction from the Eiffel community was, of course, to write a paper saying if you had used the Eiffel language, this never would have happened. If you think it's harsh on the Scala mailing lists, you know, at least you're not getting it from the Eiffel guys. But they actually wrote a very well-reasoned article about why the Eiffel language would have prevented this disaster. And I have a little demo to show you why. In idea. What do we have here? Okay. Wrong way. There we go. So we have a rocket class that represents the Ariane 5. It has a speed. It starts out not going anywhere, and you can accelerate it and start the engine. And the problem, it seems like a reasonable API. Rockets don't really decelerate. They slow down, I guess, but I'm no physics guy, so let's not get into it. The problem with this is that you can do a whole bunch of invalid things to the object through this API. For instance, you can create a rocket and start accelerating it before you even start the engines, and nothing in the API is going to stop you from doing that. The API is temporally coupled, and there's nothing to stop you. You can start the engine twice, which makes this horrible grinding noise on the launch platform. And I did that. That's why I don't drive anymore. And so there's a whole bunch of invalid things you can do with this rocket. Let's see if I can. I think one of the valid things you can do is actually execute it. Let's go. Yes, success. Launch, you know, rocket just blew up. I work on web apps, like thank God, right? It's, but the point, let's look at that area. Oh, here it is. Let's look at this Ariane 5 class again. So what's so special about Eiffel? Has anybody used Eiffel? Designed by contracts? Designed by contracts. So the idea of Eiffel is that you'd specify the contract of your class within the source code. And I think the Java community on a certain level has really embraced contracts. When we talk about interfaces, a lot of times that's the wording we use. We say, what is the contract of this object? What does it need to do? And of course, you can implement an interface and totally not do that. There's nothing that prevents you. But Eiffel, the language, it's designed around trying to give you language features that tell you what an object's contract is. If you need to start an engine, if you're not allowed to start an engine twice, then you would express that not in a unit test, but in the source code of your object. You would specify the contract. And what I'm going to show you, this is a Groovy class. So I've added some annotations. This is from a framework called G-Contracts. It's just a plain old framework on top of, it's just a Groovy framework. It's not doing anything special with the language, but it is doing code generation. That's why it's an example here. But what we've expressed here is that this method requires that the engine field is not started, and it ensures on the output that the engine has been started. And so this is these are the prerequisites and post conditions of this engine started now. And if you were to run this script again, you'd see rocket.startEngine is called twice. And if you were to run this script, you're going to get an exception saying precondition to method startEngine is violated. And so you're no longer allowed to do that. So you have, in design by contract, you have preconditions and you have postconditions to method calls, and your class as a whole has an invariant that it needs to, that always needs to be true. And we can see we can see all of these features are available in G contracts. This is just an annotation, and within it we've put a method call or some code that gets executed. We've put a closure inside of it. Within the accelerate method, come on. This is an interesting one. Accelerate requires that the engine is started and the parameter is greater than 0. So within these closures, you have access to fields, but you also have access to the parameters that the method's called with. And you also have access to the original values on postcondition. So if you want to ensure that the old value is less than the new value, the thing is accelerating after all, then this would be the postcondition that you would write. And as a last, I mentioned invariance before. See if I can get mine to go. And the class invariant is that speed always has to be greater than 0. It's a rocket moving forward. There's no gas pedal, it just goes. And you can see trying to run the bad rocket will throw an exception because it's an invalid use of the API. And, well, this isn't very interesting, but just to prove it, if you use the API the way it's meant to be used, it presumably fires off. Right? So the idea of design by contract is in the design process to think about what the preconditions and postconditions of all your object interactions are, and let that guide how objects behave. Design by contract is trademarked by the Eiffel Group. So I guess we're doing contract by design or something. So the contracts describe the valid test results. And so again, for me, I am a Groovy user, but I am definitely a Java user as well. And I think the Java type system has some faults. It's not as good as some other languages, but I definitely like that you can specify things at compile time and have them enforced and know that they're true. And that's why I think design by contract appeals to the Java community, is that we are interested in correctness on a certain level, but we've embraced unit tests because we know that no single tool is going to give us an absolute correct, or we're not writing proofs, right? We're writing business applications for the most part.
Do you know contract for J? Because it's very similar to this one. You can also express some invariants, and it's like, it's not based on compile time code, but it's AOP. So it's very similar.
So aspect J, what is it? No.
It's contract for J.
Contract for J. I've heard of it. I haven't looked at it. The advantage there is that it's at compile time. A runtime exception doesn't do a lot of good 2 kilometers above the atmosphere. Yeah, things fall back to Earth eventually, I guess, but you collect the pieces and start over. But that's one of the deficiencies, I think, of a Groovy-based approach, is that these are runtime exceptions, not compile time exceptions. So that's a good point. So Eiffel envy is what I call this Java obsession with contracts. The #1 bug in the Oracle database is to add contract support for Java. It's the most voted bug. And so, yeah, I think we do get fixated on correctness. I don't think G-contracts is any sort of silver bullet. It's an interesting framework to look at. And it's interesting to think about what code as you look at these annotations, it's interesting to think about what code needs to be generated under the covers to make this work. Obviously, when a method is being called, the bytecode is being written to make some assertions about the input and the state of the object. It's making some assertions about the output and the final state, and then it's capturing old variables. So this framework was written in pure Java. It only runs in Groovy, of course, because of the syntax that's allowed, but the actual framework is completely Java. Nope. Look at these. F5, huh? Nope. It says F5. I don't know. Max. So, Eiffel envy. I have like 4 out of 5 of those symptoms, by the way. And the problem, I said it earlier, the problem is the contract has to be written correctly in the first place. And you're just because you're using design by contract doesn't make it a defect-free environment. That would be a bit of a joke. And the rules for inheritance become really complicated, in my opinion. So next, that is one example of a code generation project that under the covers is generating that code. 2008 Jolt Award for lamest logo. Ring any bell? Find bugs? Right? Like, my favorite part is it's trademarked. They're worried that someone is going to steal Buggy. Yeah, I'm going to open a business somewhere with weak copyright laws and just use that as my logo. But Find Bugs is a really good project. Static code analysis in general does feed into this desire for correctness, to desire to prove that things are working correctly. Find Bugs right now has about, well, what it is does anyone use Find Bugs? Heard of it? Okay, so Find Bugs looks at your class files and determines when something incorrect is happening. For instance, inconsistent synchronization is one that IntelliJ IDEA has in the IDE with a notification, and Find Bugs has as a class file rule. What it tells you is when a field is being accessed in a synchronized and unsynchronized context. So if you have a field and you're writing some values and it's all synchronized nicely, and then you come in later and you add something new and you forget to synchronize on it, it creates an error for you and says, don't do this. The message is a little different, but you get the point. And this is very helpful. I really think checking tools are a lot better than mentally going over it. For the Groovy community, we have a competitor called CodeNarc. CodeNarc doesn't look at the bytecode, but it looks at the syntax tree that's created by the compiler. And I believe that other tools work there are some other tools as well that do this. And looking at the syntax tree that's created during compile, it will give you some of the type information. It will give you a tree of your entire program that you can look at and analyze and determine what's going on. With Groovy, it's a dynamic language, so you don't have as much type information. It's very reliable in telling you that something's an object, but that doesn't help that often. And the problem with Find Bugs is that there's 67 rules compared to 364 rules for Find Bugs. So that's another. Okay. Find Bugs is another one of these Groovy transformation or code generation frameworks. that is built on these same set of features. It's looking at AST, it's manipulating the AST, the tree of what your program is. And for embedded languages, this is an example of a, this is another example of using code generation. This is something I wrote for one of my customers. We needed to expose to a customer a scientific calculator, basically. We needed to say, we need to give you a miniature language. I don't want to say DSL, it's maybe an overused term, but we need to give you a miniature language. The example with language tools is always to create a calculator, and I looked at some of the examples as quite frightened. But what we did was we used, we'll look at the details in a minute, but we used, again, AST transformations within Groovy to expose basically Groovy to the client, but the only thing they're actually allowed to do is anything in the math library and anything with numeric computation. If they try to create a file or create a socket or create anything else, there's a security exception. And we did that within about 300 lines of code. And most of it was just throwing security exceptions saying you're not allowed to do this. So it was a very, I thought, a clean usage. This is, if you download Groovy, this is actually in the samples directory. You can see it. And one last example of what, one last example, come on. There we go. One last example of how far you can push code generation in Groovy is something called the Spock framework. The Spock, named after Spock, wasn't obvious. This is a framework for unit testing and acceptance testing. And you can see that this isn't even valid Java code, or valid Groovy code for that matter. Using a pipe is an OR, and there's some carriage returns there. You have some go-to labels. It's really, from a syntax, from a semantics point of view, in any sort of standardized Groovy or Java, it's really nonsense. I think I have, yes, a demo of Spock. Oh, these shortcut keys. This would be so smooth if with a normal keyboard. All right, Spock. So, this is a unit test. Some of the things that are not valid are go-to labels. This identifier, so this is a go-to label. Normally you would want to see this execute by stopping here. You would see this normally execute from top to bottom. Let's see what happens. All right, yeah, so the first breakpoint we hit, of course, is the bottom of the method. And then when we advance, F8, nope, that's not it. Run, F10. No. Anyone know the Mac hotkeys? Continue is F9? And Mac has that? No. Damn. Crashing and burning.
You have to use FN together.
The next line of code that's executed is the one above it. One last try and then I'll quit, really. Resume. There we go. There. Woo. They make it so hard. Oh, Jesus. Stop. Okay, so what is happening here is that this is a table-driven test, and so the point is that in your where block, your where block is going to execute before your expect block, and it's a table-driven test. And so in your where block, you try to make a wiki-ish formatted data, and the expect block is going to be executed with rows from your table. And so here, this expect block references an input and an output variable. And you can see that there's columns here. One's called input, 1 plus 1, 2 plus 2, and the output is your expected results. And it does pass. And there's since there's 3 rows in your table, if you unrolled this, you'd actually see in your JUnit results you would see that this executes 3 times. So your test runner, it actually looks like three tests. So Spock is built on top of JUnit, so it has IDE integration. This little bronze circle is an artifact, I think, that's been fixed using the last release. But the point is that just as a framework writer, the author of this framework really drastically changed what it is, what a meaningful Groovy script is. What is the time before I go too far over? Time check. 45? Okay, we're good. So this is a table-driven test. The other option within Spock, let's look, math, data-driven. There's also another option that also creates rows, and this is meant to be used with data from a database or lots and lots of test data. And so it's an interesting. The point of even doing this is to make it really clear what the input and output of your tests are. At the same time, also integrate really well with all the existing tooling, like JUnit and the IDEs then. So Groovy is a compiled language. It's not an interpreted language. It's compiled down into Java classes, just like everything else on the JVM is compiled into. And the semantics, what is meaningful code in Groovy now with the ability to do AST transformations is really open. You can write quite a few things like G contracts, Spock. These are all just frameworks that are built on top of the language. And normally you would need language changes to do them. So the whole John McCarthy is the inventor of Lisp. He said language should have its own abstract syntax. And here he is telling you you're doing it wrong. I was accused of being this guy in code reviews, so I toned it back after my peer review. I don't believe in peer reviews. So an abstract syntax tree is, I mentioned it before, many languages, when they compile, turn your source code into a tree representation. There's a root node, and then executing or compiling just walks the tree and performs that, or walks the tree and outputs something for that, for each leaf in the tree. A compiler will output bytecode for each tree, for each leaf. So the Groovy compiler, the JVM class is a stack-based format. So the Groovy compiler and the Java compiler, for that matter, are just walking a tree and spitting out the class file. So this is what Lombok does with Java C, is my understanding. It does that with their Eclipse plugin as well. This is what the Groovy compiler does. This slide's not that good. 1 plus 1 is 2, hooray. And if you want to look at the AST for that, I said it was a tree. Well, on the JVM, everything is a class. You can't execute anything that's not a class. And so what I did, I'm sorry, that was maybe a little quick. What I did, this is Groovy Council. It's just a standard tool in Groovy. When you download the binary, you get it. I did inspect AST, and you can see what your code is. So there's a class. It has constructors, methods, and fields. There's a main method. It's a class of type script, so there's a run method as well. And then within there, you can see in a tree view that there is a binary expression, and that has two leaves, 1 and 1. So a binary expression with a leaf of 1, a leaf of 1, eventually gets transformed into 1, 1 plus 1 and executed that way. Right? Let's go back. A more interesting example, def x and y, that should be 3, hooray. Looking at the AST, again, you have a block statement, that's the top level branch. You have a declaration expression, x equals 1. You have another declaration, y equals 2. And then you have a binary expression, x, x plus 1. And so I could do more examples and show you that it really is a tree, but you have to believe me, it's a tree. There's a tree view of it. You can't get away from the treeness. So everything's a tree. And this is what this, so when I say that Groovy is extensible, that you as a framework writer can change the semantics, this is what you're dealing with. You're dealing with a tree. And with a lot of languages, you're dealing with a tree. At some point, like with FindBugs or CodeNarc, you might want to walk the tree and observe things and decide what's illegal and spit out error messages. Many IDEs work this way as well. With G contracts, obviously there's going to be a node somewhere about an annotation, and you're going to collect some information about that node and try to insert new nodes and insert assertion statements as nodes. The demo we just did. How it works, there are this is a local transformation. A lot of these examples required an annotation, and Groovy gives you the option to automatically hook an annotation up into a AST transformation class. So really all you have to do is write an annotation and point it at your transformer, and you get called back when the compiler hits you. So @delegate works that way. @synchronized would work that way. They've written an annotation. @requires is one of the G contracts annotation. You've written an annotation. It's just a plain old interface, Java interface. And then you have an AST transformation subclass where you have access to the tree. You can do whatever you want to it. The Groovy compiler runs. It's sort of a black box. And at the end, you get new bytecode. So some people aren't visual, more text-based. You would write an actual interface in plain old Java. You would write a subclass of AST transformation. There's this black box that's the Groovy compiler, and at the end you get new bytecode. So there's two presentations of it. It's so this one. Yeah, it's pitch dark. This guy. Yeah. The top is just showing the first one is just showing an example usage, and again, there's a few examples there's examples in the Groovy source code. 5 or 6 language features are written this way, but in the examples directory, there's 2 or 3 examples as well, and the Groovy wiki has more details. But basically, you write a plain old Java interface saying, @ whatever, and when that thing is called, when Groovy the compiler sees that annotation, it's going to take that whole source bundle in a tree form, and it's going to give it to your implementation.
So it's an aspect in compile time or during compile time?
It has it's a part of the compiler. There's a hook for it. It'll call you back. It's not an aspect in the like AspectJ sense, I think. Maybe after the session, maybe we'll talk. I don't know.
Well, I would understand it that way. Just it's aspecting the compiler process, not the runtime. But it seems pretty similar to me.
I can't say anything about AspectJ because I really don't know anything. We'll edit that out later. I should be honest, I don't really know anything about AspectJ. Spring Roo works off of AspectJ's compile time inner type definitions. I've looked into that a little bit, but so it's the fourth black box. Let's get a move on. And so once you have this AST, what do? And the classic way to walk AST is with a visitor pattern. There's an interface you can implement that has one method for every single type of node in Groovy, like a block statement, a for statement, a while loop, a ternary statement. There's an Elvis operator in there. And so you can write a visitor that can modify whatever it is you want to modify. Again, in the case of G contracts, there's a visitor to watch for preconditions and postconditions, collect some new information, and then write the new bytecode out. It doesn't write the new bytecode, it adds to the tree, and downstream the compiler writes the rest of it out. As a simple example, this is a CodeNarc rule to try to find system.run finalizers on exit. This is a way to mask concurrency problems typically. This is a visitor that would basically override visit method call expression. And if the left-hand side of your method call is system and the right-hand side is run finalizers on exit, you can be pretty sure that is that method call invocation. You can't be completely sure because there's a lot of dynamic things that can happen in Groovy. So this is the whole rule within CodeNarc. Pitfalls. The worst pitfall is that there's only 5 minutes left. So there's a couple pitfalls I want to mention. Testing AST transformations is fun, I think, because you get to think about all the code that could trigger it or cause it to break. There is a class called Transform Test Helper. So in Groovy, and so if you want to test it, it basically in a unit test will call your transformation and transform some code. So it's not actually a pitfall, but this is in Groovy 1.7. It's very easy to use. So testing it is actually not much of a pitfall. It's quite easy to do. Writing AST is the type hierarchy of an abstract syntax tree can be quite complicated. There's a type for everything in the system, and so that means, 50 or 60 types. For me, it reminds me of trying to learn the swing type hierarchy, and I sort of burned my mind out with all those types, and it's hard for me to remember that stuff. This is manually writing out the AST for a new print line. So if you want to do some compile time magic for printing something, you have to learn this. This is not a compliment. Or you can use what's called the AST builder. So the AST builder itself is one of these transformations, and it takes whatever code you have in your braces, and it doesn't execute it. It compiles it and hands it back to you in tree form. So if you're interested in taking this further, Groovy Council has the AST viewer that lets you view the tree. AST Transform Test Helper lets you unit test the tree. And the AST builder helps you write AST in the first place. And it tries to create an abstraction over this big type hierarchy so that you don't need to know about it. It has a large, it has a more than just a simple API. I wish I didn't have animations, I could just skip that. One of the difficult things right now, and this really is difficult, no jokes on this one, is that taking code from the calling context, within your transformation, you're given a chunk, you're given a tree, and to weave things into that tree is very difficult. For instance, in this example, you can see we're using the AST builder to create the AST for a new print line, and it's calling original.name, which is a parameter to this method, and then it's calling the original code, and then it's doing another print line. And this isn't valid code right now. If you have within your transformation, if you want to sort of combine information from the calling context and what you have, you can't do anything like this, and you a lot of times end up having to write the AST by hand. The reason I am talking about this is that the language Boo has a very easy syntax to do this same thing, and it worked. I'm plugged in. Oh, you better so. I'm just not a Mac guy, am I? I'll be done in a minute. So this is the Boo code. We're looking at something very similar for the next version of Groovy. We're calling it AST templates. This is the gap number for the proposal for Groovy 1.8 of how this would look, so that you'd be able to mix and match these things a little bit easier. This is any sort of experience you have with this. I'd love to hear feedback. But you can go read GEP 4 on the internet and make comments, and it's not actively discussed right now, but it's been on the back channel of the mailing list. And that's about it. There's a little Lisp in here, but we'll skip it. All right, so code generation. Good things and bad things, right? One of the textbook usages is that, like with this logging annotation, when you want to wrap something up and not execute it, so you want to pass arguments to a method and not execute them before the method's called, then compile time AST transformations are an excellent use case. The other option is when you want to start extending the language and writing something that is outside what the normally what a language would give you. Then compile time transformation is what you want to look at. So code generation happens at compile time, and that is a big benefit, but at the same time, it's hard to write reliable compile time code, and your runtime clarity is sometimes compromised. Like we were talking earlier about equals methods. If you're generating equals methods and your equals method is somehow complex, sometimes it's good to actually have that explicitly spelled out. And if there's a lot of invisible moving parts, it can get difficult both to reason about and to diagnose when something goes wrong. So that's the those are from the book On Lisp by Paul Graham, which is still sort of the Bible of writing code that writes code. If you're interested in Bibles about that topic. So the last thing is you are marooned on a deserted island with only one language. Which one do you want? And the answer's clear. I've been talking about it for 45 minutes. One with AST transformations, because you really can open up and do anything you want with the language once you have that feature in. And your language should have a sweet logo. Yeah, cup of coffee's out, man. No, I love the Java. So that's it. I've wanted to come to Prague for like years. I'm really excited to be here. My vacation starts in 30 seconds. So any questions? Could be good, could be bad. I have a question. Is there pizza left? Yes. Thank you, JetBrains.
Thank you. I have a question.
Yeah.
If you create a syntax tree which is not semantically valid, can you validate that during the compile time, or you get again a runtime exception?
It would probably happen at compile time. The compiler has several phases, and so it makes several passes over the tree. And if you, excuse me, it's very unlikely that you want to do anything in the last phase, because the last phase is what writes out bytecode, and that's not the level you want to be thinking about. You want to be more in the tree and manipulating things, and then let the bytecode producer do its work. And so if you feed bad input to the downstream phase, it's going to create a compile time error. But at the same time, Groovy is a very dynamic language. So, and you see this every day when you're programming Groovy. If you mistype a variable name, it compiles, and it's not until you run your unit test that you get an exception saying, you know, can't find variable called oof instead of foo. So it depends what you do, but error handling in general is something to be approached very cautiously when doing something like this, because if you give your users bad error messages, I think that's when I take the jar out and you know, pick a different framework. If something goes wrong and you really can't tell, that's bad. All right. Thank you so much for helping me. This is...
All right, thank you, Hamlet.